Hi, my name is Daniel Tostica,
And I'm Luke Thomas.
and we're doing problem number 7 for the video project. So here's problem number 7. Here's our graph. Basically, we're given a bunch of questions where we're supposed to basically interpret this graph and find all the available answers to the problems. So before we start anything, we start off with these two equations down at the bottom. The first one is u equals the negative integral of f with respect to x, or position. And then the next one is f equals the negative derivative of u with respect to x, or position as well. So for the first question, it asks if there are no other forces acting on the object, at what point is the net force acting on the object 0? To solve this, it's very simple. We just find out where the slope of the graph is equal to 0, and we found it to be equal at 4 meters right here. So you see slope is 0. At 7 meters right here, slope is 0 again, and then at 9 meters as well. Slope is 0 right here as well. All right, next question. At B, at x equals 2, 4, 6, 8, and 10 meters, what is the direction of the force acting on the object? So for this question, we have to look at this equation again, f equaling the negative derivative of u with respect to x. So with this equation, we're basically saying that if there's a positive slope, there is a force in the negative direction, and if there's a negative slope, the force is in the positive direction. So for at x equals 2, direction of the force would be at positive x because the slope of it is negative going down. At 4, there is no force right here, as we stated earlier, so therefore there is no direction as well. For number 6, for 6 at x equals 6, the slope is positive, so therefore the the force would be negative. So right here, negative x, and it's so on and so forth. With 8, it's 8. The slope is negative, so it has to have a positive force direction. And for 10, the slope is positive, so it has to have a negative x direction, as we stated here. Now for problem number C, is the force acting on the object stronger at x equals 1 meter or x equals 2 meters? That's very simple. We said it was at x equals 2 meters because the absolute value of the slope is greater or steeper than it is at x equals 1 meter. So as you can see here, x equals 1, it's kind of steep, but at x equals 2, you can see a very increasing vertical drop in the slope. So therefore, we said that at x equals 2, the force is much stronger.
Now, question D asks us, the object is initially held at rest at x equals 1 meter and released from rest. What is the velocity of the object at x equals 7 meters? To solve this problem, we're going to find the change of potential energy between the positions x equals 1 and x equals 7. The change in potential energy can be found with the graph. At x equals 1, you can see the object has 300 joules of potential energy, while at x equals 7, the object has 200 joules. The change in the potential energy goes to kinetic energy, so the kinetic energy is 100 joules. If we solve 100 equals 1 half mv squared, we find that the velocity is 10 meters per second. POE asks us, the object is initially held at rest at x equals 8 meters, then released from rest. What is the maximum value of x that the object reaches, and the minimum value as well? So it starts at this position right here at position equals 8 meters. And now it's going to move towards positive direction because that's the direction which the force would push it. And the maximum distance it would reach would be x equals 10 meters. Because if it falls down this way, it will gain kinetic energy but lose potential energy. It then will move back up, but it can only get as far as x equals 10 meters. Similarly, the minimum value of x it'll be at is x equals 8 meters, because it will never go further to the left. POF says the object is initially at x equals 1 meter and has velocity plus 5 meters per second towards positive x. If the maximum value of x that the object reaches is x equals 6 meters, how much energy is lost to friction between these points? So it starts at x equals 1 meter and moves to x equals 6 meters, where it stops. At x equals 1, the potential energy it has is 300 joules, and its initial kinetic energy can be found using 1 of mv squared, where v equals 5 meters per second. So we find that initial kinetic energy is 25 joules. So initial energy is 300 plus 25 equals 325 joules of energy at x equals 1. At the final position of x equals 6 meters, the object loses, at x equals 6, the energy is 150 joules. So it loses 150 joules of potential energy. But this goes to kinetic energy. So the initial energy and final energy is the same if there was no friction. But the question says the object stops at x equals 6 and how much energy is lost to friction. So that means if it stops, the only energy that it can have at x equals 6 will be potential energy. Since it is not moving anymore, kinetic energy will be 0 because the velocity is 0. That means 150 joules it loses between the two positions goes into friction, is work done by friction. So the energy lost is 175 joules, and that is the work done by friction.